It's working. Great. It's working. All right, so we are recording, and let's go over it. If you need to stop me at any point because I'm moving too quickly or you have a question, feel free to do so, okay? Take as many notes as you possibly can so that you understand how to do it. And since I'm able to record, if you don't get all the information written down, I'll post this in the shared folder, and you can go back to the video and get the questions written down. All right, number one, it says short answer. I got to change that. This is multiple choice. The terminal side of an angle in standard position lies in quadrant 4 on the coordinate grid. Hey, I know the coordinate grid. The radian measure of the angle could be which of the following? So here's what we know. We know that we have some angle, and we know it terminates in quadrant 4. So basically, this question is saying which of the given angles terminates in quadrant 4. And so maybe what you did is you went through each answer choice and checked to see where it terminated. 6 pi fifths terminates in which quadrant? Quadrant 3, yeah. Remember, the key is to realize that this is pi over here, which is in general, in this case, 5 pi fifths. Okay? And if you're not sure where it lives in relation to that, half the numerator, half of 5, is whatever this is going to be up here. So that'd be 2.5 pi fifths. And now you have your quarter cycle counting interval. Every quadrantal angle is another 2.5. So down here would be 7.5 pi fifths. And then all the way around, of course, would be 10 pi fifths. So you can do that for any denominator, any partition. Well, of course, now 6 pi fifths, you know, lives over here between 5 and 7.5. So that's a quadrant 3 angle. That's not the one we want. Letter B, 3 pi fourths. You know that from the unit circle. It lives in quadrant what? 2. Okay, so that's not it. C, negative 2 pi thirds. Ooh, getting fancy. Negative 2 pi thirds. That's going to live in quadrant what? 3. Good. Because 2 pi thirds would rotate into the second quadrant. And so the negative angle rotates through 2 quadrants but lands in quadrant 3. D, negative 7 pi thirds. Now that one is a pi thirds reference angle, but it's bigger than one rotation, isn't it? Okay, because one rotation in terms of pi thirds would be 6 pi thirds. So we're going all the way around. That's negative 6 pi thirds plus how much additionally? Another pi third. Okay, so that would be negative 7 pi thirds. So that does live in quadrant 4. We're going a full rotation clockwise plus another pi thirds in the clockwise direction. Now that is the answer, but remember, maybe if there's still one more, maybe there's a better answer, maybe there's 2 correct answers, maybe Mr. Corpy messed up on the test, or maybe we did something wrong already. So 16 pi 11ths, if you want to check out where that guy lives, this one requires maybe a little bit more thought. There's 11 pi 11ths over there, pi. Half of 11 is what? 5.5, so that's 5.5 pi 11ths. So if I add 5.5 to 11, I get 16.5 pi 11ths. So that tells you that's what it is down here at 270. So we are stopping just short of 16.5. So that is a quadrant 3 angle, which is not the right answer. So the correct answer is D, as in, dang, I'm having fun already. Or D, right answer. Okay, either one. Questions on number 1? All right, number 2. In circle O below, the radius of line segment OB, remember that from geometry? Line segment OB is 5, so that's also line segment OA. And the arc length is 5 feet from A to B. So there's 5 feet, 5 feet. The measure of central angle AOB, which is this angle here, theta, is which of the following? And if you preview your answer choices, you have 1 radian, 60 degrees, greater than 60, pi radians, 5 radians. So 3 of the 5 are in radians, and 2 of them in degrees. So what you know about answer choices, maybe the answer is going to be some kind of radians, because there's more answer choices with radians. That's not always true. But here we have an arc length, and we have a radius and a theta. Do we have any formula that relates those? Yeah, S equals R theta, which actually comes from the definition of a radian, which is S divided by R. The arc length formula comes from the definition of a radian. But if you wanted to start with the arc length formula, that's fine. You can plug in and then solve for theta, or solve for theta and then plug in. I'm going to solve for theta and then plug in, because I want y'all to remember the definition of a radian. It's the ratio of the arc length to the radius. What's the arc length? 5 feet, and I know my 5 looks like my S. And then the radius is also 5 feet. So not only do the units divide out, sort of the numbers, and we're left with 1 radian. That's the definition of a radian. A. So on tomorrow's test, maybe the answer is not 1 radian. Maybe the arc length is 10 feet, right? And the radius is 5, in which case the measure would be what? 2 radians, okay? Something like that.
So it's not 60 because it's kind of equilateral triangle angle. Or because that's the arc length.
Yeah, it's not 60 degrees because it's 1 radian, and 1 radian is about 57 degrees. Okay, so that's why it's not 60. You're not really sure just by looking at it if it's 60 or not, but once you know that the answer is 1 radian, which is about 57 degrees, you know the answer is not 60. And you also know it's not greater than 60 because 1 radian is 57 degrees, which is actually less than 60. So if there was an answer choice here that said less than 60, now there's 2 correct answer choices, and that's not going to happen. So to dismiss answers choice B and C from contention, you kind of had to know what the answer was. It was 1 radian. And remember, 1 radian is about 57 degrees. Okay, sweet. Number 3, there was a question like this on the worksheet. Except the one on the worksheet dealt with arc length. This one was a little bit easier because you didn't have to do something once you found your angle. Through how many radians, theta, does the minute hand of a clock turn in 48 minutes? We don't know how big the clock's minute hand is. We don't need it because we're just figuring out the number of degrees. So here's 12 on the clock. So the minute hand can start there. Just a good point of reference. 48 minutes can happen anywhere, but if you start at high noon, then 48 minutes is going to be somewhere over here. And we're essentially trying to figure out that angle theta. Well, how do we figure out theta? You start with the rotation, right? When the clock minute hand moves 48 minutes, it moves what fraction of a rotation? 48/60ths of a rotation. Good. It went through 48 ticks all the way around. All the way around is 60. So it went 48/60ths of a rotation. Now all we have to do is convert rotations to what? Radians. So rotations in the top. I have 1 rotation in the bottom. And 1 rotation is how many radians? 2 pi. So there's your conversions. Notice your rotations divide out. And you're left with 48 times 2 pi divided by 60. Now if you preview your answer choices, they all have pi visible. So you can do one of 2 things. With the calculator in your hand, you can do 48 times 2 divided by 60, math, enter, enter. And then stick pi back in. But that takes some of the fun out of it. So let's go ahead and do it another way. Let's go ahead and divide out the 2 and the 60 to get 48/30ths. And then 6 goes into that. 6 goes into 48 8 times. It goes into 35 times. And we'll stick pi in there. So 8 pi/5. However you want to do it. You have a calculator again tomorrow. Whatever you do, if you're going to do math, enter, enter, don't type the pi in there. Leave the pi out because it's visible in your answer. Math, enter, enter. The answer is D again. As in, dang, this is going well for me. Or as in, dude, where's my car? I never saw that movie. Did they ever find it? It's been so long. Right. All right, dude, who would have known that that would have been a movie? Secant of negative 47,537 pi/6. Okay. So what do we know about coterminal angles? Coterminal angles have the exact same trig value. Now, there were 2 ways to do this problem. You could have put your calculator into radian mode, and since you don't have a secant button, you could have typed in 1 divided by cosine of that number, and you would have gotten a decimal. And then all you have to do is go through all your answer choices and type them in and see which one of your answer choices matches up to that decimal. But that, again, takes some of the fun out of it, so I'm not going to do that. So here's what I'm going to do. I'm going to figure out what the coterminal angle is that falls within 1 rotation. I do know it's a pi/6 reference angle. So that and that alone, you can kind of eliminate some of the answer choices. Because at any pi/6 reference angle, the ordered pair is some kind of square root of 3 halves 1/2. And the secant is going to be the reciprocal of cosine, which is 2 square root of 3 over 3. So you know your answer is either positive or negative 2 square root of 3 over 3, which that and that alone gets you down to either choice B or E. So if you're going to do a guess, now 50-50 is better than a 20% shot. So let's figure out where that angle lives. I am going to use the calculator, but I'm going to figure out where that angle lives. So remember, when you have a radian angle, what you do is you take the coefficient of pi/6, which is negative 4,7,537, and you divide it by what? 12. Always twice the denominator. Because that's how many radians 12 pi/6 in 1 rotation. You kindly add back the full rotations, 3961, thank you very much. And then you always remultiply by the exact same number you divided by, which is 12. What that does is it gives you, remember, your new coefficient of pi 6. So secant of that angle is the same as secant of negative 5 pi 6. Now you might know where negative 5 pi 6 lives because you're rotating clockwise. But if you want to get the positive angle, because it's what you're more used to, no problem. We just add one more full rotation back to that. And one rotation is how many pi 6? 12. So if you just add back one full rotation, you're going to get secant of 7 pi 6. And now it's like you're taking one of those times unit circle quizzes, right? Piece of cake. 7 pi 6 is in which quadrant? 3, where secant and cosine are both negative. So your answer is E, negative 2 square root of 3 over 3. So I don't care if you did it that way, or you actually just guessed E, or you typed in cosine, 1 over cosine of that angle, and then matched it up with the decimals by typing in all your answer choices. That's why you get tested in two formats, right? There's a possible way to arrive at the answer without doing it this way. Well, then all your answer choices will probably be, I wouldn't ask you for the secant. I might just ask you which one is coterminal with it between 0 and 2 pi. Yeah, so that you can't just type it into your calculator. Yeah, so that's really what this one is testing. Do you know how to find coterminal angles? So if I were to write this question again for tomorrow and I took the secant off, which I'm glad you brought that up, maybe it says which of the following is coterminal with that angle between 0 and 2 pi? And of course, then the answer would be what? 7 pi 6. So I do expect you to know how to do that. So whether I put it behind a trig function or ask you like that, that's how you do that type of problem. All right, now number 5 was the one problem that dealt with the trig whip activity. It was the only one. And I wrote it on Saturday morning because I was thinking, wouldn't it be cool to have a huge merry-go-round, a huge one? So I wrote this question. The platform of a large merry-go-round. How large, you ask? Well, let's read on. 200 feet in what? Diameter. Now, why in the heck is diameter in bold? Because I'm nice. That's the right answer. Because I'm nice. And, of course, the diameter then is not the radius. And we need the radius for our calculations. So what is the radius if the diameter is 200? 100. It's not the only problem on this test where you had to use the radius from the diameter. Okay? So to the nearest mile per hour, how fast does a person standing on the very outer edge of the platform travel if the merry-go-round makes 6 revolutions per minute? And I gave you a hint so you knew how many feet were in a mile. Again, I'm nice. So the calculation is this. V equals R omega. This is what you did on your trig whip activity. The radius is 100 feet, and the omega I gave you is 6 revolutions per 1 minute. So if you write it like that, with the 1 minute in the bottom, you can use stoichiometry. Now, if you multiply those two together, you get 600. And I'm disappointed in myself, truthfully, that I didn't put 600 as an answer choice. My bad. But that's not the right answer because if you look at the units, that gives you feet revolutions per minute. And are feet revolutions per minute the same as miles per hour? No, hardly. So we have some conversions to do. So let's focus on the conversions. Let's do the feet first. It's feet over 1. So if I have feet in the numerator and I want them to be gone, I have to put them in the denominator. And I want miles to appear. So what's the conversion? 1 mile is 5280 feet. So if you're not getting the right answer and you're not doing stoichiometry like this, good luck in the future, okay? What's beautiful about dimensional analysis is because you know exactly if you're going to get the right answer if your desired units in the end come out to be what you want. All right? So things divide out from high to low. So now I'm left with miles, which is what I want, but I still have revolutions in the top. And what are the units of revolutions? Revolutions. Yeah, so let's get rid of the revolutions first. Revolutions in the top, so 1 revolution. I need to replace 1 revolution with some other unitless measure of rotation. Radian. So 1 revolution is 2 pi. Now, if you want to put 2 pi or 2 pi rad, it's up to you. The revolutions divide out, and if you want to draw a line through rad because they're really not there, that's fine. So the only units now left in the top are what? Miles, which is what I want. But if I type it in now, I'm going to have miles per minute, and I want miles per hour. So the last conversion factor is to get rid of minutes. I currently have minutes in the denominator, so I want minutes to be in the numerator. And if I can go straight to hours, that'd be great. What's the conversion factor? 60 minutes, 1 hour. Minutes divide out. And now take inventory. In the top you have miles, in the bottom you have hours. Is that miles per hour? Heck yeah. And so now all you've got to do is type in exactly what you see there into your calculator. You don't even have to worry about the ones, right? Because multiplying and dividing by 1 is the same thing. So it's all the other numbers. So here we go. 100 times 6 divided by 5280 times 2 times pi, or 2 pi, works like that, times 60. And if you had another factor in the denominator, you say divided by, right? Hit enter, and you get what you know to be the right answer. It's 42.839 mph. Now it says to the nearest mile per hour, so if you round up, you get 43, which is the correct answer. So that would be a pretty cool ride. 6 revolutions per minute is not very fast. That's 1 rotation every 10 seconds. But because it's so big, when you're standing out at the end, 43 miles per hour, that's pretty exciting when you're out at the end, right? Cool. That was almost as fast as how fast y'all were going on the exhibition trig whip activity. Who was out the end? Was Rylan, were you on the end? Yeah. Yeah. I still watch that video once a day. It gladdens my heart. It was fun. It was fun. All right, number 6, the goat problem, which got some people's goat, unfortunately. I wanted to make this the free response question, and Mrs. Lincoln objected. So I made it into a multiple choice question. Now, you don't need the diagrams there, but this was not a difficult question. Some people made it more difficult than it needed to be. Okay? One person in first period said they would just cut the rope and let the goat rope free because it's 100 by 100. All right? Why would you even tether the goat if it's in a 100 by 100 foot field? Okay? Call PETA. A goat is tethered to the side of a 10 by 10 foot shed. The tethering rope is 18 feet long and tied to a post in the middle of one of the sides. So that's this diagram here. This is 18, and there's 5 feet clearance on either side because it's a 10 by 10 shed. What is the total area, and again I say on both sides, for the goat to graze? Assume that the shed is in the middle of a 100 by foot field. That just means that there's plenty of room for this goat to swing out. One side, underlined and bolded, is illustrated below. So it's going to be able to go over here on the other side just as easily. Okay, so that's why I said on one side. So I'm going to focus on the left side, and then once I find the left side, all I got to do is do what to get the total? Multiply by 2. All right, so let's focus on that. All right, so you don't need to see the numbers. The numbers are irrelevant. I gave you the picture so you can see what's happening. This is a right angle right here. Okay, and this is 5. So as he swings out to the right, he comes out over here. This is an 18-inch radius. And what portion of a circle, then, is that sector? Because it's 90 degrees, it's a perfect fourth of the area of a circle. So you didn't need to use the area of a sector formula. If you did, your angle would be what? Pi halves. And it works that way. But because it's a perfect fourth of a circle, you could just use the area formula of a circle and divide each by 4. So a fourth of a circle. So when you do that, now he could turn the building. Because it was 18, there's still how much left over if this is 5? 13. So now if he turns the corner, the building kind of keeps it tight here at 5, but he still has a 13-foot radius that he can sweep on the other side. So this radius is 13. Now because the building is only 10, he is going to stick out another 3 feet beyond that building. So when he sweeps through that final arc, there's 3. So basically what you have is 3 pieces of circles that are each a fourth of the total circle with different radiuses. The radiuses are 18, 13, and 3. So here's the easiest way to do the problem. The total area is going to equal 2 times beefy bracket. 2 because I'm going to do it on the other side. And it's just 3 quarter circle calculations. So it's pi r squared divided by 4 plus pi r squared divided by 4 plus pi r squared divided by 4. And again, you could have used the area of a sector, but know that it's 1/2 r squared theta, and theta is pi halves in each one. This is just a little bit easier. Okay, so what are my 3 radii? Because we have what fraction of a circle for each of these? It's a fourth. It's a perfect fourth of a circle because the angle is 90. And 360 divided by 4 is 90. And the area of a circle is pi r squared. So you take a fourth of it. So your radii are 18, 13, and 3. And there's your setup. Okay, so you could type all that into your calculator, but that's a lot of typing. So let's be a little bit more wise about how we could do this. What do you know is common now in each term? Pi fourths. Let's go ahead and factor out the pi fourths, which when we multiply by the 2, we get 2 pi fourths, or pi halves, times, and now it's just 18 squared plus 13 squared plus 3 squared. And that's a lot easier to type in. Less possibility of error. Okay? Now, you are probably not going to be calculating goat areas the rest of your life, are you? So that's not the purpose of learning pre-cal. What's the purpose of math education? To get you to do what? Think. Because that, hopefully, you will be doing in the future. So you always have to think about how to set up the problem, and you always want to think about, too, if there's two ways to do a problem, is there a more efficient way to do it? And it could be as simple as, like, using quarter circles instead of area of sectors. And it could be like, how can I make typing that in easier? Okay? Do a little bit more work on the front end so the work on the back end is easier. Simplify early and often is what I always say. All right, let's go ahead and type that in and see what we get. So pi halves, pi divided by 2, times the quantity, 18 squared, plus 13 squared. I think it's 169, but I'm not sure. I'll let the calculator do it for me. Plus 3 squared, I know that's 9. I'll save a keystroke. Yeah, go me. Hit enter, and you get this fantastic number of 788.539 square feet. Yeah, good question. Why am I multiplying by 2? That comes from careful reading. To the nearest foot, what is the total area what? On both sides. And then one side is shown. So there's your key. I want you to do it on 2 sides, and I'm only showing one side. So why am I multiplying by 2? Because, again, there's another one over here, there's another one over here, and there's another one over there, and they're perfectly symmetrical. So whatever I get on one side, I'm going to get on the other. Right. I was going to write this as a free response, as I mentioned, and then I was going to say, if there's a guy standing in the middle of the back of the building right here, and he's afraid of the goat, will the goat be able to get him? Really? No, because this radius is 3, so he can come 3 feet in on this side, and he can come in 3 feet on this side, which leaves what as an insulation area over here? 4. There's 4 feet of protection space right here. So as long as he stands in that 4-foot space, the goat can't get him. Yeah, the goat is, he can maybe get him with his back legs. If he gets his neck and then turns around, he can probably kick him. But then this guy can feel free to, like, go over here, unless there's 2 goats. See, I was going to make a wonderful free response question. There is no tree. I would have written the question without a tree. Okay, yeah, cool. So that's why we're doubling it. Now, here's another way you could have done this question if you know anything about test design. There are only one pair of answers where one is twice the other or one is half the other. Only one pair. And that's the 789 and the 394. So, based on test design, you might anticipate it's one of those two. And because you know you're having to find twice the area, maybe then you would take the one that's twice as big as the other. So without doing much work, maybe 789 would be the obvious test. That's test-taking strategy as opposed to math strategy. But that requires you to do what? Think, which is what I want you to do. So having said that, maybe on tomorrow's test, I have 2 sets of answers that are twice the other. Oh, man. Oh, okay, sweet. Number 7. You're still thinking about the Freudian pizza? So I wrote you a question with Archimedean pizza. Archimedean pizza has the main topping of sand. It's not widely ordered. Okay? But if we take a wedge-shaped piece of pizza cut from a 12-inch what? Diameter. Now, it wasn't as nice this time. I didn't bold diameter. But if the diameter is 12, guess what the radius is? 6. And if you use 12 as the radius, there was an answer choice for you. So here we go. The radius is 6, so that's 6, that's 6. And this is r theta. This is the arc length. It's r theta. So that's going to be 6 times whatever the angle is. So if we keep reading, The angle measure of the pointy piece, I actually typed that in there, the pointy piece, so you knew which one it was, from the center measures 38 degrees. If A is the area of the sector and P is the perimeter of the pizza, what is the value of A plus P? Okay, let's figure it out. First things first, 38 degrees is not going to be a usable format. I'm going to have to use it twice, once for the perimeter, once for the area, so I'm going to convert it off to the side one time. And what's the conversion factor if I want degrees to divide out? I need degrees in the denominator and radians in the top. What's the conversion factor? Pi over 180. Yes. So if you simplify that, you get 19 pi 90ths. It doesn't simplify very much at all, but it's 19 pi 90ths. Well, if you use degrees, let's see. We'll try it. Here is what I'm going to do. I'm just going to set it up in one setup. A plus P is equal to, all right, what's the area of a sector? It's 1/2 r squared theta. And theta is 19 pi 90ths. What is the radius? 6, okay? 6, I'll put the units in there. It's 6 inches. So, Trevor, why can't we use degrees? Well, right now I have inches squared times radians, which is what? Inches squared. If I had that as degrees, I'd have inches squared degrees. Inches squared degrees. Is that a unit of area? No. The degrees mess it up, so you have to use radians. Anytime you use length or distances, you have to use radians. Plus the perimeter. Now the perimeter, remember, you have to walk around the slice. So it's 6 plus 6 plus the arc length, which is 6 times the radian angle, 19 pi 90ths. So some people miss that. It's 6 plus 6 plus 6 times 19 pi 90ths. All right, so here is your A, and here is your perimeter. And now all you have to do is type it in. So if you set it up like this, you don't have to find the area first, store the decimal. Find the perimeter next, store the decimal, and then add them together. You can just type it in one line, and there's really no way to simplify that. Can't factor anything out, so here we go. I'm going to type in 0.5 instead of 1/2, times 6 squared is 36, I'm pretty sure of that, times 19 pi 90ths. You could have stored 19 pi 90ths as A, so you could save some keystrokes. But there's the area, and then plus 6 plus 6, which I know is 12, but I'll go ahead and do that, plus 6 times 19 pi 90ths. Hit enter, and you get the number. Oh, I put 90. Yeah, see, that's not an answer choice, thank goodness. 90ths. There we go. 27.917. And that would be, well, the units don't make sense anymore because we're adding feet to square feet. But it's just a number that's an index of the size of the pizza. And if you round, it's 28. So it's A. So tomorrow I might ask you to do something else with A and P. Instead of adding them, I may have you subtract them, or I may have you divide them or multiply them. It's just a way for you to find both, but I only have to type in one number as an answer choice. So that's the real reason I do that. It's easier for me. Okay, so make sure if you're given diameter and you need radius, you are truly using the radius. Don't just use the numbers that are given. Again, you have to think. Because that's the perimeter. So if you look over here, the perimeter is walking all the way around. So there's 6 plus 6, that's walking up the two sides where the radius is, plus along the curved crust area, which is the arc length. And how do you find arc length? It's r theta, which is 6 times 19 pi 90ths. So you're going to have 6 plus 6 plus 6 times 19 pi 90ths. Okay. Moving on. Number 8. The terminal ray of an angle theta, kind of hard to see the theta there, passes through the point negative 24, negative 215. If your angle theta is between 0 and 360, what is theta? Well, this is like everybody's favorite 2 clues problem because it's very difficult to get it into the wrong quadrant because you know how the coordinate plane works. It's negative, negative, so it does end up in quadrant what? Quadrant 3. So negative 24, negative 215. I'm just going to draw that. If you drop a perp, this is negative 24, this is negative 215. Now, if you know it lives in quadrant 3, can you eliminate any answer choices? It's got to be between 180 and 270. Can't be B, can't be C. Okay, but it could be any of the others, right? All right, so now you don't need to find the hypotenuse because, remember, if you have the x and y, you have both the tangent and cotangent. Which one should we use? Tangent. We have a tangent button. So whatever theta is, I'll mark that as theta. We know the tangent is y over x, which is positive 215 over positive 24 because the negatives divide out. So to solve that, which kind of leads up to the free response, we get theta equals inverse tangent of 215/24. Now, what mode should we be in? Degrees. When does it matter what mode we're in? Occasionally. It doesn't matter if you're converting from degrees to radian. The only time it matters to be in the right mode is if you are ever going to be typing the sine button, the cosine button, or the tangent button. That's it. Whether you hit second sine or sine, it doesn't matter. When you hit one of those three buttons, you better be in the right mode. Well, I'm going to check. I'm in degree mode. Nice. It's always the first thing. Now, here I go. I'm going to hit second tangent. See, I just hit the tangent button of 215 divided by 24. And because I paid good money for my calculator, it always gives me the right answer. So that must be the answer, right? No, but it is an answer choice, right? And again, if you put that as an answer choice, you are not doing what? You're not thinking. Because 83.630 is in quadrant what? Not 3. Quadrant 1, which makes sense. I just told the calculator, hey, calculator, give me an angle whose tangent is a positive ratio. It knows tangent's positive in quadrant 1, and that's the easier one to find. So the calculator's kind of lazy. But remember, the calculator then gives you the reference angle, which happens to also be 83.630. That's the reference angle because it's already positive and acute. So your diagram then tells you to get to your terminal ray, you go all the way to 180 plus that amount. So all you have to do to get your angle is add what to that number? 180. So let's go ahead and do it. Plus 180, and you get 263.630, which is answer choice D, as in donut. As in, do not do this problem in radian mode. That almost worked. Okay. Questions on that one? All right, number 9. You had questions like this on the worksheet, but of course this actual specific one was not one of them. So again, if you're looking for just something that is the same with different numbers, that would be tomorrow's test. But in the future, that's not it. You have to understand ideas, concepts, and you can't really study for a math test. Rather, you have to practice for a math test. And remember, you cannot cram practice. You cannot cram practice. All right, sine of some angle theta is negative 0.4. We have to figure out what sine of the negative angle is plus the cosecant of that positive angle. So I guess we need to figure out maybe where theta lives. Well, given a negative ratio of sine, I know that theta has to live in either quadrant 3 or 4. So let's just kind of do some hypotheticals here. If theta lived over here in quadrant 3, if that were theta, then where would negative theta live? It would live over here in quadrant 2, right? And what do we know about those two terminal rays? They have the exact same reference angle, which means they're going to have the exact same magnitude of sines. All right, so in that case, if negative theta lives in quadrant 2, sine is not going to be negative 0.4, but rather positive 0.4. Now, the other quadrant where theta could have lived is over here in quadrant 4. So if that's theta, what would negative theta look like? Well, it would rotate all around over here, and it would be in quadrant 1. In either case, whichever quadrant theta lives in, negative theta is going to live in a quadrant where sine is positive. And so, what is sine of the opposite of theta? It is the opposite sine of the sine I gave you. In this case, it's positive 0.4. Okay, plus, if sine is negative 0.4, then cosecant should be what? 1 over negative 0.4. Because how are cosecant and sine related? Reciprocals. And there it is. So all you have to do now is type that in. So here we go. 0.4 minus 1 over 0.4. And you get negative 2.1. You did it a completely different way? Was your way easier? Oh. How did you do it? Well, it's plus a negative. See what I did? You're adding a negative. So if you want to put plus, that's fine. You just got to say 1 over negative 0.4. Or 1 minus 1 over positive 0.4. Whatever you want to do. How'd you do it, Trevor? Oh, yeah, you can actually find an angle. And it doesn't matter which angle you use, right? You probably, if you did inverse sine of a negative number, you probably got a negative acute angle. You got a quadrant 4 angle. And that works. And then you can just type it in. Yeah, sine of the opposite of that angle plus 1 over sine of the angle, and you'll get the exact same answer. That's fine. Great. I'm glad you brought that up. That's another way to do the problem. Do I care which way you do it? Not at all. Not at all. Okay, sweet. How could I prevent you from doing it that way, Trevor, in the future, now that you brought it up? I could say if sine of theta equals negative a, what is this in terms of a? Now it would be a plus 1 over a, which would be a squared over a plus 1 over a, which would be 1 plus a squared over a. So maybe that would be now a better pre-AP question. Well, I got a common denominator. I multiplied by a over a. Yeah. Why do I drop the signs? Well, this one is positive 0.4 because negative theta lives in quadrants 1 or 2 where sign is positive. And I actually have to keep the sign. This is a plus sign here, so this is a plus sign. But the cosecant ratio is still going to be negative because the sine ratio started off as negative. And I'm not doing anything with the angle there. It's the exact same angle. So if I know the sine ratio, the cosecant is just the reciprocal. So that question is really testing two things. Do you know what happens when you rotate clockwise versus counterclockwise? And do you know the definition of a reciprocal function? All right, in the time that remains, very quickly, let's go through the free response. If you did the twos clues problem, if you did the worksheet problems, and if you paid attention in class, this should be a much easier problem than it turned out to be. But you do have to be in the right mode. All right, part A, draw the reference triangle and draw the arc. Some people didn't draw the arc. So secant is negative when x is negative, which is quadrants 2 and 3. And cotangent is positive when x and y are the same sign, which is quadrant 1 and quadrant 3. So the overlapping quadrant is 3. So the angle lives in quadrant 3. And then you had to draw the triangle. So there it is. So that was the first part. Get it in the right quadrant. Now, for the rest of the questions, we're going to need to find things. So let's go ahead and do that. If secant of theta is negative 6, what's the definition of secant in terms of x, y, and r? R over x. Now, remember, x and y could be positive or negative, but r is always what? Positive. So the reason it's negative 6 is because it's actually 6 over negative 1, not negative 6 over positive 1. So now I have two sides that I can label. The radius is 6, and x is negative 1. So you did get one check for drawing the reference triangle without it being labeled, as long as you drew the arc and you have the triangle there. But we do need to find the y value, and some people are still using the quadratic formula incorrectly. I cannot fix that at this point, okay? So here's how you would actually use the quadratic formula. Y squared plus the quantity negative 1 squared equals 6 squared. You can't just arbitrarily take any two sides. What did I say? Quadratic formula. Yeah, some people are probably using that wrong too. Pythagorean theorem. Thank you. Thank you. The Pythagorean theorem. The quadratic formula. That's another good one, though. Yeah. Anyway, talk about not thinking. That was me right there. Pythagorean theorem. You cannot just arbitrarily take any two sides, square them, and add them together. It has to be the hypotenuse that's isolated. So when you solve for y, it's plus or minus. It's now going to be 36 minus 1, which is plus or minus the square root of 35. And I was nice. On the test, I gave you a radical that did not simplify. But on the twos clues, every radical did. So tomorrow on the retest, if you end up with something like the square root of 45, I would expect you to simplify it. That's the same thing as 9 times 5, which is the square root of 9, times the square root of 5, which is 3 square root of 5. But 35 is 7 times 5, both of which are prime. Now, the sign does matter. Which one of those do we want because we're in quadrant 3? The negative. So you got another check for committing to negative square root of 35. There was the second check. And now that you have all 3 sides, you have all 6 trig ratios. So here we go. Part B, cosecant of theta is r over y, if you want to write that. That is going to be 6 over negative square root of 35. But that is not rationalized, is it? So now if we rationalize it, we get negative 6 square root of 35 all over 35. And that would be another check. That would be the third check. Tangent of theta, very quickly. Tangent of theta is y over x, which is negative square root of 35 all over negative 1. And if you simplify, you just get the square root of 35. That's your fourth check. Now, that is not the only time you're going to see that number. Right? Close your eyes. Open them up. There it is again. It's not the only time you're going to see that number. Close them. Open them. There it is again. We've seen it 3 times now. It'll show up yet again. All right, part D. Find the reference angle. Show the equation you're solving. You can solve any one of these following equations. The safest one is to use cosine. If secant of theta is negative 6, then cosine is negative 1/6 because that was given. So you could have had theta equals inverse cosine of negative 1/6. Now, some people were not showing an equation. You got to check for that. If you left off the theta equals, that's not an equation. That's an expression, and you're going to lose the check tomorrow. Theta equals. You could have done that one, which was safe. You could have also have done, what else could you have done? You could have done inverse tangent of the square root of 35. That one works nicely as well. But now you have to have faith that you use the right one. Or you could have done this. You could have done inverse sine of negative square root of 35 over 6. So any one of those would have gotten a check. All right, that would be the fifth check. I'm going to go ahead and use the inverse cosine. And I am in degree mode. You need to check. If you got 1 point something for your reference angle, you were in the wrong mode. You were in degree mode or radian mode. And I'm not going to be very sympathetic for that. I'm not going to count off just one time for being in the wrong mode. You're going to lose a check each and every time because that's like a fundamental important thing. Now, your calculator, you paid good money for it, right? So it should always give you the answer you want. Is that correct? No. In this case, the reference angle is not 99.594. Why can it not be the reference angle? What type of number is that? It's quadrant 2. It's obtuse, right? Some people are calling negative angles reference angles. Some people are calling obtuse angles reference angles. Again, at this point, if that's the mistake you're making, that's not good. That lives in quadrant 2. So to find the reference angle, I need to do 180 minus that. So the reference angle is 180 minus 99.594. And I'm going to show that equation. So now I'll just go 180 minus that answer, second negative. And now I have my reference angle of 80.405. And then finally, to find theta, your picture tells you that you just need to do what? Go all the way to 180 and add the reference angle. So the last part here that we'll do, the actual value, theta is equal to 180 plus the reference angle, which, since the reference angle is still there, I just say plus 180, and I have no rounding error. And you get 260 degrees, 0.405 or 406 if you want to round, that's fine, degrees. And you're done. And that was the 8th and final check. So this test was worth 17 points. Oh, the slope of the terminal ray, finally. In terms of theta, yeah. In terms of theta, the slope is pretty easy to find. It's just the tangent value. If you put the square root of 35, you were super close, but that's not in terms of theta. I wanted you to realize it was the tangent ratio. Okay? The tangent is always going to be the slope of the line because it's y over x. You'll be able to get the same reference angle, yeah. What do you mean, what's the answer? To F? Tangent of theta. It is wrong because it asks you to give it in terms of theta. Yeah. Remember what we did right here? Yeah. There it is. Yeah, and that's exactly what you could do. You can actually create 2 points and find the slope. Here's the point, negative square root of 35, or negative 1, negative square root of 35, yeah, and then 0, 0, right? That's great. That's a great place to start. Then you're going to get the slope is the square root of 35. But that's not in terms of theta. So then you realize that that's just the tangent ratio, and there's the answer. All right, have a good day.